Hello, everyone. I think we can start the meeting because the first part of it gonna be mostly administrative, while the folks will join us. Welcome to the second day of the AI-DGGS workshop. This is an outreach event for the OGC AI-DGGS for disaster management pilot. My name is Sina Tagavikish, and I am a R&D project manager with OGC. Before we actually commence with today's activities, I would like to mention some administrative remarks. Again, similar to yesterday, I would suggest that all attendees mute their microphones. The discussions and panel sessions will be conducted in an open format. So please do not hesitate to join in into our discussions. The way it's going to happen is that our panelists, comprising of the participants, the sponsors, and the OGC staff, will signal their intent to speak by basically raising hand in teams to respond or basically define or set a new question. Uh, as for the general attendees, I would recommend that you submit the questions via the chat, so we will have the written version as well. And if your questions is unclear, or if we actually do have time, we kindly ask you to unmute yourself, briefly introduce yourself, and pose your questions. Same goes for the participants. Please just state the name. For example, this is Sina speaking, and then answer your question or set out your question. So, without further ado, let's delve in to the very short slides that I have. Um, just checking the chat. Okay. Yeah. So the OGC AI-DGGS team is actually as myself, which, as I mentioned before, I'm a project manager with OGC and the COSI sides of it, and Ingo Simones, which is our chief technological officer, that actually helped with the ideas behind this pilot. Uh, I would like to again thank our sponsors, which is NRCan, USGS, ESA, and CANES. And for the agenda today, we missed two presentations from yesterday. So gonna give those two participants 10 minutes each to present their results. That will give us some idea and maybe some even more context for today's discussions. Then we will have an overall summary of the first day that will provided by Stelius, by Hartis, and then we will have the first panel, which gonna discuss the flood risk discussion. That's gonna be moderated by Ryan Ahola from NRCan. And the second, then we will have a short break. Then we will have the second panel, which is the DGGS discussion. I will run that panel. And for the third and the final panel, which is going to be an interesting one as well, it's going to be about AI discussions. So Stelios Kontarinis will run the third panel, and that is basically it. So if we have somebody from Crim, maybe Francis, to share his slides,
Yes.
then we can start with that. Yes.
Is it visible for you?
Yes, perfect.
My name is Francis Neo. I work at the Computer Research Institute of Montreal as a senior software developer. During this pilot, we work mainly on the server implementation of DGGS. Our objectives during the pilot were to evaluate the potential of DGGS as an alternative to the traditional GIS APIs, such as features, maps, coverage, and so on, and to integrate it along other such standards in our platform to evaluate the interoperability potential. We also evaluated the potential for AI integration to observe if the potentially AI could better leverage DGGS, as we observed in the previous pilots, the climate disaster resilience pilot, that we had a lot of challenges with AI that had trouble understanding coordinates and spatial relationships. So we're hoping that DGGS can help solve that. And we wanted also to integrate the API into our climate services platform. So making sure that their considerations for operational deployment are considered in our implementation. Our contributions were provided to various open source repositories. Firstly, there's the AI-DGGS API, where we collaborated with the University of Tartu and GeoLinks for providing a daytime-aware DGGS, that is a DGGS that can respond across space and time using different filtering strategies with temporal slicing and reporting the data of each zone across time. We also developed the alternate DGGS responses that were not supported by the API at the time that the pilot started, such as DGGS UBJSON with extra compression capabilities. We also added some filtering and query tooling so we can better retrieve specific zones of interest. We added some collection geodata metadata based on OGC API comment part 2 to make sure that we can have a better traceability of the originating data source of the data that was represented with DGGS. And we also added the Docker service implementation such that we can deploy it in our platform, which depends on this technology. We contributed to the DGGrid for Pi by improving the Python wrappers that were provided, adding support for DGGrid version 8, such that we can employ the fixes and optimizations that were provided in this version. Then we also work along the DGGrid itself by ensuring some capability and compatibility against the other DGGAL library that is very common in this domain. We observed with other participants that there was a lot of compatibility issues dealing with authalic and geodetic latitude values. So inevitably there was some shifts in zone IDs that were not represented in the right coordinates between different libraries. So we found some values to solve these. And we also address some issues regarding high resolution DGGS grid generation, where because of default values used by the library, there was incorrect generation of certain grids at very high resolution. Finally, we add the contribution to the birdhouse ecosystem, which is the infrastructure as code that we use for deploying to many Canadian organizations for climate science study. So this is integrated and deployed on our Hirondelle server for demonstration. During the testbed, we did a few during the pilots, we did a few explorations. First was the regarding the DGGRS registry and the metadata. We observed that across the various libraries that define DGRS, although they use the same terms, such as IZIA 7H or IGO7, they have slight discrepancies. So as mentioned previously, authalic and geodetic latitude are not considered the same way. There's some issues with H3 that doesn't or claims to be using certain datum definitions, but differs from what we can see in the observed results. So these discrepancies highlighted a need for an official OGC registry that properly describe each of the DGRS in detail and all of their parameterization so that each implementation can align together. There was also some issues with how the IDs of the specific zones are represented. For example, the IGO7 and IZA7H plus the Z7 indexing system that represent essentially the same zones, but with different IDs to identify the zones. So these needs to be differentiated and probably cross-reference between each other to provide some information about their compatibility. We explored also the DGGS datetime aware response. As mentioned previously, we have some climate portal integration where temporal is absolutely necessary. So we wanted to ensure that DGGS is not considered just as a spatial zone index, but also allows all the relevant spatial slicing and querying, temporal slicing and querying. So we added these functionalities, but we observe a lot of issues where sometimes you have holes in data sets, and representing these holes might not be very efficient when there's really a lot of holes and just a few values in sporadic locations. So evaluating the sparsity of the DGGS responses and how alternative representations could be used to better leverage efficient data transfer. These were explored during the test, but during the pilot. We also faced some aggregation challenges between some collections that use temporal information and others that don't have it. So how to make sure to aggregate this in a coherent fashion so we can have a response that includes both collections with their different temporal consideration. We also explored the storage backend. So one of the common approach that seemed to be used is to employ the DGGS UB-JSON for high compression, but for the same reason as the various sparsity of data that we observe, we started exploring the Parquet, which is commonly used in stack catalogs, for instance, and we found a few optimization that can leverage the indexing that Parquet already use to represent directly the DGS zone IDs, saving a lot of storage space. And since only the relevant zones of interest are stored in the database, there's really a great compression there by not storing empty zones. So we explored how to potentially leverage that Parquet representation for performing more efficient data search with specific zone IDs, and also because of the Parquet representation itself being a tabular definition, we can see some great potential for AI use that basically don't have to worry about the coordinates interpretation as you just deal with a single ID. It's easier to do pattern recognition, and the IDs themselves are already encoded in a hierarchy, so it's easy to let the model look at the values of the IDs themselves and figure out some kind of spatial relationship just by the way they are encoded themselves. Lastly, we did an exploration for the DigiGal and DigiGrid comparison. So as I mentioned a few times before, there was a few discrepancies. This is illustrated in the figure, so we can see that the pink zone is the result that we would obtain from DigiGrid normally if we didn't tweak the result, but the expected one is the yellow one just under. So there's an offset which create some issues if we don't correct these, since the DGS responses omit entirely the definition of a coordinate, and we rely on the libraries to reverse engineer the coordinates corresponding to the zones. So by the exploration that we did with these libraries, we were able to figure out the relevant parameterization so that clipping of zones and the generation of the grid is aligned between the different libraries. The collections that we produce are essentially including the temporal based on the stack RCM RD data provided by NRCan EUDMS has been quantized to the IGO7 DGRS representation, and it deals with the various O's such as presented on the left figure. So you can see that the satellite pass went partially over the zone of interest, so it deals with the missing data values and all these concerns across space and time. And there's the Canada population dataset that we encoded with H3, also with sparse representation, so represented on the right image with resolution 10, I believe, or 8, something like that. This is it for my presentation. If you have any question, do not hesitate or look at the repositories. We're happy to receive contributions and collaboration with different partners. Thank you.
Thank you, Francis. If you do have questions, please put them in the chat and we will respond. I mean, Francis will respond back, but we will have lots of time for discussion, hopefully today. So let's move to the second presentation for today, which is the last presentation for the participant, and that's Nicolas from CS Group France.
Hello, can you hear me?
Yes, we can hear you and we can see it. There's
Yes.
the slides.
Perfectly. Okay, fine. Thank you, Sina. I'm Nicolas Villard. I'm working for CS Group, which is an intermediate company, a medium-sized company located in Toulouse. We are a company specialized in geospatial activities for different domains, mainly for space, defense. In Toulouse, we have acquired strong skills in hydrology domain. So we have many projects for CNES, for European Space Agency, and the French Ministry of Environment about hydrology. And here are some of the customers we are working with in various government space agencies. We recently joined the OGC this year, last year. And we are quite new to OGC at CS Group, but we made in the past we led different projects related to DGGS before standardization by the OGC, and following carefully all the work led by OGC during test beds. And so we developed a few prototypes. Here is one example of what we did 2 years ago for ESA, a demonstrator capable of exploring data cubes based on Copernicus Sentinel data and exploring time series, displaying the raster data and dig into radiometric indices. More recently, we worked with STAC and used DGGS to display the result in a very user-friendly way, to aggregate the result on different collections and catalogs. So I will pass quickly on the objectives of this pilot, which was the main was to how to get the tools we have in AI and the large language models to explore collections and data sets available and made online by the partners on this pilot. and identify any missing part in the DGGS specification. So we wanted to develop a client as generic as possible, and which is able to connect to and tie with as many partners as possible. So this point illustrates how we connect to different endpoints and with different DGGS collections and reference systems. On this slide, I will present very quickly as well the high-level architecture. Our client is mainly developed in two independent components. The first one is the client itself, which is using long chain for the orchestration, and which contains all the intelligence, if I can say, of the client, with different prompts and at least a series of tools which are made available for the agent. So it can execute remote code, but also local code and business logic if we want to make some computation based on the data which is retrieved by the client and so on. And it contains also as well the user interface and for the chatbot and the map. The second component is MCP server we developed, which really does the queries and the requests to the API providers. And we delegated to this MCP server all the queries and interactions with the DGGS APIs. And so the idea is that the agent is able to select the right tool to do the right operation. A few words about the different challenges, because we have a lot of collections made available by the partners with different DGGRS. So some are supporting more the DGGRS than other. It can be tricky to handle different collections at the same time. How to integrate the DGGS API with the chatbot was also a challenge, as well as defining indicators and computations based on the data we retrieve from different endpoints. That's some features where we spend some time. And how to connect to external services when needed. Maybe for geolocation, we used external services by the agent to locate cities and a point of interest. We get some challenges in the API retrieval itself, because the current specification is picking data, is allowing to retrieve data from a single cell ID, and based on the parent-children relationship. So we made some interesting discussions about that, and Geomatis proposed a new endpoint for this. We had to deal with different DGGRS, and that was not an easy task at the beginning of the project, because we were depending on different libraries. And finally, we adopted DGGAL from Itere, which was really a game changer and which simplified a lot our work of integration for visualization. At the beginning of the project, we were using H3 for the same reason, as it is very common and well supported by different visualization toolkits. And we highlighted some issues with it as well, as we discussed yesterday. And one of the biggest challenge was to create a simple, user-friendly interface to ask questions to the different data available, and which is very responsive and fast, because we are working with vectorized data and not working with raster. So we need efficient and fast visualization toolkits. Here is a very quick demo of the demonstrator. You can see it's split in two. You have a list of instructions which you can send to the demonstrator, and a map viewer to display the results. So I prepared yesterday a simplified video for because we were short of time. The idea is to show you how we can create complex tasks using a single prompt instead of decomposing a step-by-step process. So what I'm asking the agent is to look at the different providers and different collections available and find information about floods, about population, and to create a simple indicator based on the two first layers. It seems frozen. Okay. So when we launch the process, the agent determines itself which tools to use. So it starts exploring the different collections available and to geolocate the area of interest. So I asked to analyze on the Winnipeg area. So so the agent is geolocating Winnipeg and then list collection. Find relevant collections regarding population and flood, and then it dig into the collection details and check all the fields available and in which DGGRs they are available. And once he finished, so is able to create a map with different all the layers I asked. And what's interesting is it is able to explain the process and the iteration. So we can see the three data sets I requested and how he managed to get them and explain the mapped field he used from different collections. So that's two collections from Examine. One was pretty obvious, flood cause was interesting. It matched what we requested. For the population, it was not as easy because the field name was grayscale, which is not very straightforward to understand. But he managed to create a link and use it to map the population. So then he created the flood rate, a very simple flood risk index, combining the two layers. That's just a simple example to show you the possibilities, because the agent is able to self-explore and create his own steps and following a simple scenario written by the user. Okay. So in the next steps, we have highlighted the need to define a standard way to write complex scenario using single prompts or to pre-compute some scenarios. And we face some issues related to the metadata as well, which were not very accurate in some cases, and so the agent couldn't determine very well only by the names which one to use. So that's maybe a point we can dig further. And we found also that these technologies could also be suitable for other API, OGC API standards, such as OGC features, record, and process. So DGGS could become a universal way to query raster and vector data, but this is quite promising. But today, up to today, of course, many software and libraries have to be adapted, and the DGGS specification should be implemented. Yes, that's a new paradigm, and but very, very promising. And that's it for my presentation. Don't hesitate if you have any question.
Thank you, Nicola, for this presentations. And yeah, so with this, we are done with the presentations from the other day.